آه وين يا شباب، السلام عليكم ورحمة الله. زي ما وعدتكم هعمل لقاءات مع بعض الناس المتميزين هنا في ستانفورد. وحال ما امشي ان شاء الله اذا لقيت شخصية متميزة وزول ما شاء الله عليه ونعمل معه لقاء. فاليوم ان شاء الله قبضت لكم واحد اخو عزيز بول، دكتور بول، وحنعمل معه انترفيو ان شاء الله. Welcome Dr. Paul.
Thank you.
Let's first start. You introduce yourself maybe first.
Okay. So hi, I'm Paul. I'm a research associate at Stanford University. I've been here for 3 years. I work in physics, mainly in optics, and I apply my technique and what I know in optics and in physics to space science. So I'm working in the space science group, and the goal of this group is to make tests of physics while putting experiments in space. So the main experiment on which I'm working is basically a clock, which is based on it's kind of atomic clock, but it's a molecular clock. Perhaps I could explain first what's a clock. I come from France. I've been working in Toulouse, which is in a big city in the south of France, close to Spain. My main area of work was metrology, which is a science of measurement of related in optics. I was working with magnetic fields. The goal of my PhD was to test laws of physics. So I've tried to make an experiment.
So this was in your PhD?
It was in PhD, yes. So basically I had to build an experiment which was testing the fundamental physics.
Can you tell them a little bit about your experiment, some details, like what did you build in France?
Mm-hmm.
And what type of standards or what kind of standards did you try to test?
So it was, so as I say, metrology experiments. It was to test how light behaves when it propagates in a magnetic field. And there is a law, which is quantum electrodynamics, which predicts that light should be slowed down when it propagates in a transverse magnetic field.
Slow down. He slowed the light down.
But this effect actually is very, very small, very tiny. It's 10 to the minus 24, so it's 0 and 24
Is
zero.
that time, you mean, talking about time scale?
Yes, it's
okay.
a very, very small effect.
10 to minus?
10 to minus 24.
10 to minus 24 second?
Not exactly, it's an index of refraction. It's a difference of index of refraction.
If you want to convert that to time scale?
Time, no, it's less than a femtosecond. Very small.
To give you an idea how very fast that process, or that how short that process can take place, you take 1 second, you divide by
1 million, and then by 1 billion,
and then by 1 billion,
and you get what you have to measure.
And then it's 1 femtosecond. Okay.
This is a very small effect actually,
yeah.
And this has not been proved yet. And my work was to improve the setup, which is going to soon detect it.
Can you describe just in, let's say, in 30 seconds, how did you do that? What's
the experiment? You need light, so you need a laser, and you need magnetic field, so you need strong magnetic field. And the magnetic field
how strong?
It was about 20 Tesla. So this is a few thousand times the magnetic field of the Earth, of the Earth, even more. It's a huge magnetic field with huge current, huge voltages.
المجال المغناطيسي المستخدم، تعرفوا الام ار اي، الجهاز تاع فحص الرنين المغناطيسي. المجال المغناطيسي الموجود في الجهاز تاع الام ار اي تضربه ب 1500 تسلا عشان تتحصل على المجال المغناطيسي. How did you produce that field?
This field, you just have a coil of copper wires, and you cool it down in nitrogen, and you make strong current, a few thousands of amps going through this coil. So it's a huge current.
Why didn't you use superconducting material?
Superconducting material do not provide such big field. It's also very expensive. It's more expensive. You need liquid nitrogen and liquid helium, which is very, very expensive.
Right.
So I moved in Stanford in 2013, so 3 years and a half ago, and I started as a postdoc as Ahmed. And then I moved researcher, so I'm now a research associate in physics and especially in optics. So I'm working in a space science group whose goal is to test the laws of physics in space. So basically we make prototypes of experiment, and these prototypes will be after taken by NASA to miniaturize it and to be sent in satellites in the years in the following years. And then the project on which I'm working is a clock, which is a molecular clock. So perhaps I can explain you what a clock is in basic statement. A clock is to make a clock you need an oscillator. This is something which will oscillate, move periodically, regularly, and as the goal is to make the oscillator as perfect as possible. And for oscillator, we don't use the usual things, the quartz crystal of your watch or another clock, a usual clock. We use molecules. So these molecules are constituted of atoms, and these atoms have nucleus and electrons. And those electrons have quantum states, which is described as a quantum mechanics.
You said you're using molecules to behave as oscillators. Maybe you can explain in just a few words how these molecules can actually act as an oscillator. Is it when you say the molecules could be 2 atoms, 3 atoms? We don't know how many atoms you're going to explain to us for not now.
Yeah.
But the question is how these molecules can act as an oscillator. Is it each atom in the molecule is an independent oscillator, or both atoms and the whole molecule is itself one oscillator?
Okay, yeah, that's interesting question. So the molecules we are using is carbon monoxide, is CO. So these molecules are only constituted of 2 atoms, carbon and oxygen. And those, so they are bound, electric connection, electric bounding, and this bounding can vibrate.
So this electrical binding energy, is it because the electron is rotating around the molecule?
Yes, it's shared between the atoms.
Oh,
this makes you your molecular link.
This is one atom, and this is another
atom.
And the
electron cloud is around those.
It's not one electron, but a cloud of electrons.
Cloud of electrons, described by quantum mechanics. And so you have different states of vibration, and this vibration makes you your oscillator.
Yes.
So this is the clock oscillator.
So the vibration of the whole cloud shift, you mean?
Of the atoms, of the nucleus, of the carbon and the oxygen nuclei.
Oh, I see.
And
the nucleus.
surrounded by all the cloud of electrons.
So that means your oscillator basically consists of is a complex oscillator. It's not a simple.
It's not a single oscillator, as you have a single mode. It's more complicated. Everything is described by quantum mechanics and by quantum chemistry. Everything has been modelized by people who know very well how to use computers.
الحاجة اللي بيعمل فيها هنا في ستانفورد هو بيحاول يعمل البندوليوم بتاعنا، البندولوم او السيمبل اوسيليتر بنقول بالانجليزي الاوسيليتر. لو بتتذكروا في المحاضرة اللي فاتت انا كنت بتكلم عن البندوليوم. البندوليوم ديت من الحجم الكبير هم عملوه شنو؟ صغروه، عملوه جزيء، يعني ذرتين مع بعض عملوهم في وضعيه معينه حاسس انهم يتصرفوا كانهم بندوليوم. اوكي، فهو حيورينا بيعمل الحاجه دي كيف ان شاء الله.
Basically, to have this clock work, you need a laser, and you need to do an excitation of this pendulum, of this oscillator. So those molecules are inside this tube. So the pressure is about 10 for 100th of the atmospheric pressure, and we make a laser beam coming in that tube in which there are the atoms, and we say, okay, laser, try to be in resonance with those atoms, and we say that the frequency of the laser, that the color of the laser has to match the color or the frequency of the atoms. And once everything is locked, so we are using, for this, we are using not only optics, but we're also using electronic locking systems. So we have several lock-in amplifier, proportional integrator, derivator stages to make the thing work. And in the end, the frequency of the laser is locked, is the same as the frequency of the atoms, which is a reference which is given by the quantum mechanics.
Can you explain? Can you make it simple how the laser interact with molecules? Because we already know how the laser interact with a single atom. So you send a single photon which is coming from the laser, and this photon has a frequency that equal to the transition frequency of the electron and the outer shell of the atom, and then you excite that electron, and then the electron, once recoil back, it emits back the photon. And then you take that photon, output photon, and you measure it, which is your measurement, basically. But I don't think the case is the same as when you use molecules. So he's going to explain because you have two different frequencies this time, or maybe multi-frequencies, and you don't know which one to pick. So
basically, it's very similar to an atom. It's very similar.
A single atom.
A single atom. But you have plenty of frequency, and you need to find the right one.
Okay.
You have a lot of frequencies. That's why you need a laser which is already narrow enough to reach this transition.
But when you have a molecule, you have more than a single atom. You have several atoms.
Yes,
2 or 3 or 5.
but you have lines that are very precise, that are very well defined lines, and very well known.
That transition doesn't belong to one atom.
It belongs to the whole molecule.
Oh, okay.
The fact of having a molecule, perhaps in atoms, you're working in atoms, you will work in the visible, so between 400 and 800 nanometers. Here, this is infrared. This is a lower frequency.
And we call that molecular spectroscopy.
Molecular spectroscopy. This is it. Yeah.
Yes.
And so basically, how to say the laser, okay, be at the frequency of the atoms. We are measuring the light which is going out of this tube, and if basically this allows us to build an error signal so as to be able to feed back to the laser, so as it has the same frequency at the atoms, at the molecules. So that's it.
Oh, that's nice.
And so now this clock is working pretty well. You can ask perhaps, how can all this thing go to space? You have to know that everything can be reduced. NASA
Let's
knows.
show them around the experiment
So
quickly.
this is a huge experiment. This is 4 meters by 2 meters.
And you're planning to send this to space?
Yes,
Are you kidding me, right?
indeed. You need a big spacecraft, or you need to be clever. And I think NASA is clever to do that, because they know how to reduce the size of everything. Here, this is the uncompressible size. You need this, and you cannot have a smaller thing than that. This is where all the atoms are, the molecules are, and so the laser has a finite size. But this is a very small clock that can be sent very easily in space. So first you have optics, you have lenses, you have mirrors. You can reduce this space by using fibers. Fibers is very good, and you can shrink everything. Also, you have the electronic boxes. You can see there are a lot of space, and you have a lot of boxes that are used, and we have to set a lot of parameters. You have perhaps 1,000 parameters to set in each experiment. Once those parameters are found, you don't need to set everything. Everything is found, so everything is fixed, and everything can be reduced. So this is what I would say. And also there are chips of electronic that can be used for those experiments to reduce the size.
Okay, maybe I can make a comment on this part of the atomic chamber. And as you see, the atomic chamber is pretty large. Is a big. This one can be reduced to a size of I would say maybe this size. So it can be reduced to that size. And how can we reduce this big chamber to this size, small size, by just using the concept of atom chip? There is one problem with this approach, is that the number of atoms, the number of molecules. You need a large number of molecules, that's the first thing. And when you miniaturize the size to a smaller one, you lose a lot of molecules. That's the first thing. Second thing, the trapping field, you're going to reduce the trapping field, the size of magnetic trapping field, to be suitable for atom chip. And remember, you have a molecule, so that means the magnetic field itself will be not the same as you have it in a larger scale. But it's doable, and people did it, and I think NASA already did that, and I think retail center?
There are actually a lot of work. There's a lot of work which is done with atom chips,
Yeah.
done by NASA and so on.
Yeah.
So as to reduce the laser sources also. This is very important. Yeah.
So, can you tell us about your achievement? In a few words, what's the greatest thing you did so far? Let's say since since your childhood.
So I can perhaps talk about my professional achievement, perhaps. So, which is having been able to make something work at Stanford. It's already not easy to enter in Stanford. When I come from France, it's very little, even if it's important and it has its place in the world. It's a small country compared to the United States. And
You still have a great level of education.
we have, and I'm very proud of our level of education. This is all my country gave me the possibility of being here and of doing what I'm doing right now.
I wish my country one day.
Perhaps, hopefully it should be possible. Yeah.
أتمنى.
And so when you arrive here, you are a little bit alone, and you start to make things work. You start to learn. You start to understand what's going on. It's a new country. It's a very new area, and you start to apply what you have learned. And then in the end, you can see that you can achieve to build something which can have applications. Because this clock will be sent probably in a few years, in 2020, and this has already a very good level of instability. This clock loses only 1 second per million years. So this is very
really?
stable.
Wait. 1 second.
Per million years. This is a very stable clock. It's not the most precise clock in the world.
احنا عندنا ساعة تأخر ساعتك مثلا مهما كانت بيرفكت حتأخر يعني أجمل ساعة وأقوى ساعة احتمال تأخر ثانية واحدة كل شهر كل خلينا نقول الساعة جميلة جدا كل 5 شهور الأتوميك كلاك اللي بيعمل فيها ديت بتأخر ثانية واحدة كل كل مليون سنة ثانية واحدة.
So it means that when you come back in a million years, this clock would have only lost 1 second.
1 second in a million years.
Actually, this is impressive, but it is not the most impressive clock of the world. There are several other clocks with cold atoms, you know better than me about that, and that have achieved a greater level of stability. But the specificity, the strength of this clock is that it is very small. And when you put small things in space, it's very easy, it's cheap also. It's cheaper. It will be $100 million perhaps to this in space.
So this kind of clocks has a profound implication outside the space more than on Earth. Like the impact of its application is more realizable outside experience. Since you now you mentioned that you came to Stanford and so on. Maybe you'd like to tell us like how did this process happen? How did you arrive to Stanford?
First, so you need 3 things. You need passion. If you want to work in physics, you need passion.
And lots of failures.
Failures a lot. So you need not to lose your passion in spite of all the failures. You need work. And you need to want it. I'm in love with physics.
Okay.
I'm in love with physics. I think you are too. So these are the 3 ingredients. So there are 3 ingredients.
Okay.
Which is cooking ingredient. I'm French, so I'm
French.
to the cuisine, but it's a career cuisine. So this is first is love. You need to love what you do. You need passion. Then you need to work a lot, study a lot in books, talking with people, with friends that are learning a lot. And then you need to want it. You just need to want it and to be motivated.
So you have a desire.
You have a desire to do it. So then, to enter in Stanford, you apply for it, you contact people, you present your CV, you present your research achievement, you present what you can bring to them, and then you take interviews, then you present your work, and then they say if they are okay or they are not okay with what you are doing.
So that means you have to be you're able to build something by your own, by yourself, with no help. That's the first thing to do. Second thing is that you have to show them that your exceptional talent can brings to them a new contribution, like you add a new value to their research field. You don't have to come with a new theory, but you're going to build for them something that push the research one step forward. Last thing, as he said, is a desire. And I think this is something you can't earn how hard you work, how difficult you push. Even if you go to the finest limit in your life, if you don't have this final ingredient he mentioned to you, I don't think you can succeed, which is the desire or the love, as he mentioned to you. French people are romantic people, that's why he's mentioned love to you. الرغبة، إذا عندك الرغبة إنك تغير حتقدر تغير. What is the next step? I think this is our last question for him in the lab, and after that we're going to go outside and have a nice interview,
Taking some fresh air.
from fresh air and talk about Sudan maybe. The last question is that what's your next step? What's your plan for the future really? Like, are you going to leave academia forever, or are you going to work in an industry? So maybe you want.
So the good thing about Stanford is that it gives you the taste of academy and also with industry. So there is a big balance, a big mixture, a very good mixture between those two fields that are sometimes unrelated or too much separated. So Stanford makes the binding, makes the link between those two areas. So after having worked for the NASA, I will work for the European Space Agency, and I will work with Airbus at Toulouse, so Airbus Defense and Space.
Are you going to go to space?
Unfortunately, I will not.
Take me with you. I'll come with you, no problem.
So I will go to the Airbus Defense and Space, which is the space division of Airbus. So I will work on space mission again.
Oh, nice.
But for Europe and for my country, which is very positive for me, very grateful.
I'm very happy to hear that, and I wish if Sudan one day will have someone to interview like Dr. Paul from Sudan, from our country, and talk about going back to Sudan and working with Sudan Space Agency or Sudan Space Program. I think we should say thank you very much to him in the lab now. We haven't done yet. We have to go back outside and talk. But it was amazing how much this guy has achieved, Dr. Paul, and it's really impressive. He built all this by himself for NASA, and you can see by yourself and tell how complicated the way he thinks. This guy, his brain is just wired the same as his experiment.
And I must say also that I'm not alone on this experiment.
Would you like to say final words related to experimental work, to tell it to people, let's say, who haven't yet started looking into experimental research itself? So what's your message for someone who wants to be like you and he has nothing? He basically has to start from scratch.
This is a complicated question. I need to think about it.
I know it's complicated,
Yeah.
but imagine someone like let's talk to him in a way that he doesn't have to stop because he doesn't have the tools in his hand.
Can I say that this is what I think? Can I say that sometimes you have someone which is influencing you? You have a good influence, like a teacher, even if you're in high school or in middle school.
A mentor.
A mentor, even if you are very small, those people can bring you something that will trigger your taste or your love for the field. So be aware that you can have those people help you, and don't hesitate to go to them.
If you don't have it, you already mentioned this as your desire, as the love you have for whatever field you want. It doesn't have to be complicated space science experiment. It can be medicine. It can be medical field. It can be even working in a farm.
Yeah.
Okay. تشتغل في مزرعة عشان إنك تصلح وضع بلدك. This itself is achievement. Working on a farm itself, being a farmer, and taking care of that farm and make it producing, is not something simple. It's not. It's the same as is working in the experiment. So the definition of desire doesn't have to be heightened to places or titles. Okay. And if I have to answer his question, I will say. Listen to your heart. Okay, it's a song. I know, it's a song. Listen to your heart. But what I'm saying is, you should listen to what your heart is calling you. There is something that calling you is not attracting you because you want to make someone else happy, but because you find the pleasure on working on that field or doing that thing. That little or that tiny entity inside your heart makes you happy and feel pleasure. Is that what defines you? Is that what brings you and make you a great person? So we say goodbye for now, and we're going to see you outside. Bye.
Bye.
So hello again. So we're going to continue our interview to Dr. Paul. Thank you again for coming and
Thanks.
joining us. What did you hear about Sudan, our country? And you should be honest. Like, don't worry. I'm not gonna beat you.
To judge me?
I'm not judge you. Like, it's fine. If you
Yeah.
hear something bad about my country, you should tell me. If you hear something good about my country, whatever you heard about Sudan.
Yeah, I must say that I've already been in Sudan. When I was in Egypt, I went.
You've been in Sudan.
Yes, I've been
He didn't
in
tell
the
me
north.
this.
in
I've
the
been
North
working
Sudan.
with him for
I
don't know
forgot
for
to
how
tell
long.
you.
He didn't tell me that
But,
he'd been to Sudan.
And so it was in the north of Sudan. Actually, we went through the Nile River, and we saw civilization, Nubian civilization. So Nuba civilization, and it was very interesting because it was close to Egyptian
Culture.
pharaonic culture.
Yeah, I think there is some say that actually those pyramids they started in Sudan. But I'm glad to hear that you went to Sudan.
So, and then what I know about Sudan is actually you have I learned I did my homework that some cities in France have the same name as the name of Sudan.
Really?
Sudan. It's written exactly the same because remember when we had a French colony called the French Sudan, which is now the Mali. And
Yeah.
So it's not.
It's not the same Sudan.
Several cities in France, two have the name Sudan. So there is a link. There is a strong link.
So that means French people are in love with Sudanese?
Probably. We have a very strong link with Mali.
Mali, okay.
Yeah.
Okay, and so what's the bad thing you heard about Sudan?
Yeah, we heard. I know it through the news. I'm not a specialist of the story and of the geopolitics, but we heard about Darfur, which is on the west of Sudan.
West Sudan.
And we heard that there were a lot of refugees of war.
Yeah.
So and that was
Yeah,
issues
I think
which are still going right now.
and I feel bad about it, and I really wish if we, as scientists, if we can find a solution for the situation. Maybe when we go later, after maybe a couple of questions, we're going to talk about climate change, which I think is the main cause for the war in Darfur. I think climate change one of the main causes, because climate change caused a huge and massive dry out in that region. And those people are like big tribes. They just live with cows and animals. So if they don't have water, what they do, they move to another place. And when they find the water, that's the place where the conflict starts, because all these tribes, they want to get that water for their animals, and if they let them take it, their animals die.
Yeah, I think climate change will have big impact on refugee people, also because of the sea level is going to rise, and this will have a lot of impact on the movement of people around the world.
And I just want to add two more points. because so as to be fair, and not only just the climate change is the cause for these people to suffer from in their life. Also, the government, the politics in Sudan is somehow contributing because you didn't pay attention to those people. Those people are part of this country, this big country, and you didn't give them special attention when they have this difficult situation. You just let them in their own to try to find a way to survive. That the second point which I want to mention is the oil. That area is very rich with oil and uranium and resources, and you can interpret that as you want.
You can perhaps also see Sudan as a on the border between two continents. You have the Arabic Peninsula over there,
Yeah.
you have and you have Africa. You have Asia and Africa. So it's just at the border, just in the middle of the two continents.
Exactly.
And we know several countries that are at the border, right at the border. Let's say Israel, let's say Palestine.
Yeah.
Palestine, they are very close to Europe, Asia, and
Yeah.
Africa. So all these countries that are just at the border, just at the center
Exactly.
of all this movement of people
Yeah.
also may this can be an issue for them.
Let's go to the second point.
Mm-hmm.
And since you've been to Sudan and you drink from the Nile River, now we want to ask you to give advice to the young Sudanese researchers.
What I could say to young Sudanese and or young researchers in general is, as I said, if you want to enter in a field, to work in a field, you need passion, work, and you need to want it. This is very important. Perhaps it is also to move out of your country, like you did. This is a big step for you, I bet, and for me it was also a big step to move out of my country. So this is hard, but this is very good for your career. This will bring you a lot.
But some people, they don't have money.
Yes.
They're not able to move out of their countries. They can't just afford leaving their countries.
Yes.
That's the first thing. Second thing is the selection now in the outside universities is so competitive, so they can't survive the selection. So even if they got the chances to go out, not all the Sudanese young researchers will be able to do that.
Yeah.
So our message should be dedicated for those who cannot do it.
So let's say stay in Sudan. If you cannot move, stay in Sudan, but use all the tools that are available.
Yeah. Okay.
And what about the
he let's say he wants to go outside at some point.
Yeah.
He will be able to go outside.
Yeah.
But
But if he cannot,
then what can he do to in terms as a scientist?
Yeah, as
What
a
do you think you're thinking?
perhaps a very well-known tool, which is internet.
Okay. Here we go. This is the first thing, the first step, and then he is, let's say we're physicists and we're gonna talk to, let's say, physicists, but you can make it general. Let's say physicists, but you can make it general.
For any kind of
Yeah, exactly.
training. Yeah.
Okay, generalize this. And then it comes to equipment. Maybe you'll not be able to afford buying this equipment. But there are some experiments you don't have to buy sophisticated, like in our case, for example, it's very expensive to buy the lasers, let's say. But you still can do some experiment in physics without buying expensive equipment. And then, as a question, what type of physics they can do? Sudan is one of the hottest area in the world. Temperature can reach up to 53 Celsius sometimes. So extremely hot.
Yeah.
So imagine you have that amount of heat for a long time during the day, and you can use that heat. You can boil massive tanks of water by focusing the thermal energy of the sun. And then here we go, you generate pressure, and pressure means you can move things like dynamo, generate electricity.
energy. Yeah.
Right?
I've also heard that if you cover the tenth of the Sahara Desert of solar panel, you can provide energy for all the world.
Exactly.
So that could be useful in Sudan.
You see
of course.
that this now.
If you have sun, you're lucky to have sun. not the case of all the
think,
countries.
I think, yeah. You see, that's the point. If Sudan, let's say Sudanese people, they became open to this business.
Yeah.
Okay, they say, okay, we want investor from outside to come and build fields of solar energy. Of course, you're going to ask me a question like, okay, we generate electricity. What we going to do with this electricity? That's the point. Once you have electricity, that means you can build factories, and that means industry from outside will come to you because you have stable resources for electricity and power.
And
That's what they need.
and you have independency,
And you have
which
independence.
is very important.
Exactly. And labors, I don't think is expensive labor, and you can make the taxes are free. You know that there is a big problem of climate change, and we already now connected. We connected climate change to our problem in Darfur, let's say, and so on.
Mm-hmm.
So, in terms of solutions, what do you think Sudan can do, or Sudanese young scientists? What kind of research they should think about to do to avoid climate change? It doesn't have to be physics.
Mm-hmm.
So they have the largest river in the world,
Yeah.
and you know that you can, if you want to suppress the thermal expansion or the climate change effect, you cut the carbon dioxide simply.
Yes.
So we don't have problem with carbon dioxide, but we can reduce the global carbon dioxide by increasing the green land.
Yes.
So
I think if you want to resolve the problem of climate change, you will not be able to do it alone. Not any country in the world can do it alone. You
Okay.
need to work with other people because it's a global
Yeah.
problem, so you need to tackle it
yeah.
globally.
So what do you think Sudan can contribute globally? If you
I
want to-
think it can contribute by perhaps telling what's going on in the country. This is just
Mhm.
important because in like other country, European country, in the United States, people do not know what's going on there. They
Mhm.
are not informed well
Mhm.
of what the issues, the real issues. Here we are living in a country, in the United States, the problem we have drought. This can be important, but we are not threatened. Our life is not threatened.
Mhm.
I guess that it can be a life issue in several countries in Africa, in Sudan, for instance. This is what I think. So perhaps by telling the other people that there are problems and there is a life issue, and yeah.
Yeah. Okay. So that means the media somehow should focus
mhm.
on these dry areas where people
Yes.
they have difficulties on accessing to like water. They don't have their areas became dry, so in a way that affected their daily life. That what do you mean?
Mhm.
Okay. Our media is somehow limited. Maybe before, if you go back, let's say 10 years, they didn't have enough resources. But now look at us. We have a small camera and we're making video,
Yeah.
and this video can reach a lot of people.
Yeah.
So I think now the media should be blamed. Our media should be blamed. Why? Because they don't reach outside to those people, which is reflecting how much suffering. Okay, this is going too much politics, and we wanted to interview him just about physics and research and how.
But we did that already. We can talk about
Yeah. Okay.
different things.
Okay. So since you enjoy it, not
Yeah,
no,
yeah,
let's
yeah.
talk about politics.
I am okay with every subject.
Our last question to him, to Dr. Paul, and I'm very glad I met him and I talked to him. He's so nice person. Unfortunately, he's leaving to European Space Agency to work there, and they will send him to Mars, and he will stay there forever and will not come back again. Oh, just kidding.
I hope so.
But let's to wrap up our meeting with him, our interview with him. I want to ask him to deliver a message to his nation, to French people, and to tell them he met a Sudanese scientist in Stanford, and he asked him to give them a message. There are people in Sudan. There are young researchers in Sudan. They're so eager to find an opportunity and scholarship to come out in Europe and study and develop their skills and learn something new that can go when they go back to their lands to be really effective. If the international community somehow stands with Sudan, and took care of those young researchers and help them. That will be, I think, will change the entire area, entire zone, and stabilize that region. Maybe he can reflect this to French people, and I let him say it in French,
In French.
language. I will tell him at the end, merci beaucoup. This is the only word I know.
Donc peut-être ce que je peux dire aux Français, aux gens qui habitent la France, c'est d'aller vers les gens, d'aller rencontrer des personnes et d'aller. Donc le fait de mieux les connaître, c'est aussi moins c'est moins les haïr forcément, puisque la haine vient de la méconnaissance et la haine amène le mal, donc amène un cercle vicieux. Donc je pense qu'il faut avant tout que les gens se connaissent, apprennent à vivre ensemble, et c'est ce que les universités, les laboratoires apportent. Et c'est pour ça que j'encourage beaucoup de gens, tout le monde, à aller évidemment à l'université et dans des entreprises qui sont pleines de gens de diverses nationalités. Voilà. That's it.
Oh, I love your language. I'm definitely going to learn French language.
You have to. You have
So,
to.
merci beaucoup.
You're welcome. De rien.
And thank you. I never been in France. I never been in that country before, but I say hello to French people from here. And I think I just tell the young scientists in France, like Dr. Paul here. I think we represent a new generation. We should move forward. We should stop thinking in that old fashion, and let's try to fix our own world. We live here, and we will be responsible about the future if we don't do anything for it now. Can I say a message in Arabic? I mean, I didn't understand your French language, so you should understand my
It's very hard for me, very complicated, but I promise to learn.
طيب يا شباب إن شاء الله يعني اللقاء ده يكون مفيد بالنسبة لكم مع دكتور بول، وزي ما وعدت إن شاء الله يعني نحاول بقدر الإمكان أجي أعمل لقاءات كثيرة مع ناس من مختلف أنحاء العالم إذا قد طريقة. في نهاية المطاف إحنا عاوزين حاجتين، عاوزين فائدتين من اللقاءات دي. الفائدة الأولى يعني مثلا زي دكتور بول يحكي الخبرة بتاعته، وفي يعني يعمل شير مع الناس الاكسبيرينس او الخبره بتاعته اللي هي ما جت عن فراغ يعني. الحاجه الثانيه احنا عاوزين بالنسبه للدول العالم المتقدم، يعني مثلا زي امريكا، زي فرنسا، زي المانيا او غيره، يتيحوا فرص يزيدوا من عدد السكولرشيب للسودانيين، الشباب السودانيين اللي هم موجودين في السودان وبيعانوا من عندهم احلام وعندهم امبيشنز وعندهم دريمز، بس ما قادرين يطلعوا من السودان، ما قادرين يصلوا برا. ليه؟ لانه السكولرشيب ليميتد، يعني ما عندنا سكولرشيب، احنا فرص متاحه كثيره. فلما اعتقد من الحاجات اللي احنا ممكن نفيد نقنع بها الناس اللي برا، انه اذا الناس الموجودين في السودان تعلموا، المنطقه دي حتتصلح، ولو يتصلح ده معناها سوق جديد بالنسبه للعالم، انه السودان يرتاح، ومن الدول العالم الثانيه برضك انه شنو يعملوا استثمار انفستمنت في السودان ان شاء الله. I think okay.
That was really nice.
Oh, really? Yeah, you like it?
It's nice. It's a really nice language. I like it.
Okay, let's do this. I teach you Arabic, you teach me English.
Okay. Okay.
So
French.
French. sorry. It was a really nice idea.
Yeah, I really appreciate
We had
that.
this idea, and I think this video is going to be viral. If not, it's
We
no
can
problem.
hope. Yeah.
We're not looking for it to be viral. We're looking for people to get a benefit from what we saw in the lab and his experience, and we're very glad to have Dr. Paul with us. And thank you again for being with us.
Thank you.
It's been a
Thank you,
pleasure
Ahmed.
talking to
It's
you.
a pleasure. Bye.
And thank you.
Goodbye.